It says examine correlation and causation. We talked about correlation last time, and I think I might have briefly talked about this idea of causation. Cause and effect are different than correlation.
Yeah.
Sometimes things are correlated, but they have no relationship to each other. And you might not think that would happen, but oftentimes people believe that because something is correlated, it means it causes the other thing here.
Yeah.
And that's what's going on here. So, okay. One business owner describing a method noticed that when there are a lot of skiers in the winter, there were a lot of boaters the following summer. He wondered if there is a relationship between the two. How could he investigate the relationship mathematically? So I guess you've got to put some words down. Basically, you would want to measure the number of skiers, get the right spelling on that, and the number of boaters over a certain period of time.
Okay.
And you would want to look and graph this information and maybe find out if there is a relationship between them. So the answer to this is to actually go and collect that data.
Okay.
Is that sufficient for A?
Yeah.
You're not, I mean, you don't need to write a book here, just a sentence or a few words should be enough here. Okay. All right. So now the next thing that they're plotting here for you is they say, okay, they actually went out and collected some data. See how the answer to part A is here in part B, number of skiers and number of boaters.
Yeah.
So what this means is, like, take this first data point there in red. They're saying that when there were 9 skiers, there were 15 boaters.
Yeah.
And so on. And we assume this is in a season or maybe in some area. Interestingly, there's not that many places where you can do both. Like Lake Tahoe, you can boat in the summer and ski in the winter, but it's actually not that many places where this is even practical to do. But anyway, the data sort of goes up and to the right. I would sort of say that that's a reasonable thing to say, up and to the right. And that's why the correlation coefficient is positive. Positive correlation coefficient means that the data is going up and to the right.
Okay.
So
wait, how do I know it goes up to the right?
You're just sort of looking at the trend of the data.
Oh, okay. I thought there was like a specific word.
Let's say you were firing a gun and this was your pattern. What would you say is the trend of the person?
Shoots more.
They're going up to the right when they're firing, right? It's
yeah.
Like they're maybe I don't know, they're jerking they're doing something because it looks like it's going more to the right each time.
Yeah, it's going up more. Yeah,
because this is, and you can't really talk about it in school, but like we can. It's not a big deal, right?
Yeah, I get it.
But that's maybe something that will help here. Positive correlations go up and to the right. That was the main thing that we talked about yesterday or 2 days ago.
Okay.
Up and to the right is positive correlation.
Negative correlation goes to the left.
Down and to the right.
Okay.
Down to it's always to the right. We read left to right. We think of the right as being in the future, things like that.
Let me write this down really quick.
Okay.
Up to right is positive. Up to negative. Okay. All right, got it.
Okay. Now it says, how could they interpret each in terms of the problem and explain their reasoning so that the business owners will understand? So the scatter plot shows that as you increase the number of skiers, okay, so basically that's your X. As you increase X, because it's positively correlated, that means there's also an increase in the number of boaters.
Okay.
Simply, like saying it more simply is more skiers, more boaters. Is that clear?
Yeah, I'm just writing this down.
Okay.
Alright,
All right. Now the correlation coefficient tells you the strength of the relationship.
okay,
And the strength is because the number is very close to 1. 0.91 is very close to 1. You can say it's very strong.
okay,
The typical words you'll see are weak, moderate, and strong.
okay,
And it's kind of like disagree, agree, in between.
okay. Alright,
All right, so here we go. Part C. The business owner's conclusion was there is a relationship. To increase the number of boaters, we need to increase the number of skiers. Do you agree? Explain. So this is where we go back to what this whole lesson is about. Does correlation imply causation? And I already said no, does not. It can, but it does not.
okay.
Okay. So what you have to decide, Remy, and this really just comes from your own opinion, is do you think, and there's not a right or wrong answer, but do you think the number of boaters and the number of skiers is related to one another? Does one impact the other? Like if you own a boat, do you own skis? If you own skis, do you own a boat? If you like skiing, do you like boating? What do you think?
Okay.
And that's sort of that you have to decide whether you think that that's true or not.
If the number of boaters and skiers,
I'm asking you, do you think that those two things are related?
yeah,
Okay. So what you're saying is, and there's not a right or wrong answer. You're saying that people who like to ski in the winter, they're outdoorsy, maybe, right? So they also want to be outdoorsy in the summertime. So they're going to own a boat. And if you use the example of Lake Tahoe, where you can do both, if you lived on Lake Tahoe, you are going to have a boat and you're going to have skis. Do you have any friends that live in Colorado, Denver area, or family members or anything like that?
yeah, my uncle.
Okay, so kind of the same deal. In the wintertime, you go skiing in Colorado, lots of snow. But in the summertime, you're not going skiing. You go to the lake and you hang out. So your justification is correct. It's fine. You have to say something about that, like, yeah, they own a boat, they're probably going to own skis. You have to say something like that here. So
Yeah.
it sounds like you do agree in this case.
Yeah. This is so much like different than like normal math, I feel like.
It is very different.
It's just like it's like I don't know, it's more like it's like there's like reasoning in it too.
Do you like that?
Yeah, I do like that, yeah.
So there is an area of math that you can take more of this type of
Yeah,
math.
I'm not gonna be terrible at it.
Well, let's be fair to you. I mean, you've improved.
Yeah,
But
I have improved, but I'm just like I've naturally never really been good at like algebra and like all that
yeah,
stuff.
yeah. So the traditional math favors more the algebra, but there is an area of math that's all about this stuff.
Yeah, this seems a lot easier to me.
All right, so let me know when you get something down there and we'll go on to letter D.
Yeah, I got it.
Okay. All right. All right, another business owner said they are related, but I don't think one causes the other. Something else must be causing both. This is what's called a confounding variable. It's something besides the two that impacts it. And I've kind of alluded to it. It's like maybe if you live somewhere and you've got the money for one, you probably have the money for the other.
Yeah.
Or the fact that they're both outdoorsy type of things. It's not like they're talking about inside stuff and outside stuff. They're basically, what they're trying to ask you here is like, well, what else could be causing this? Why would you see? And it could just be as simple as people like to ski and people like to go boating. Like, it's nothing weird about that. So you've just got to come up with something here. I'm suggesting maybe like using something like income, or the fact that if you're going to live in that place where both are available to you, you're going to, like if you live in Colorado, you have a basement in your house, but if you live in Arizona, you don't.
Yeah, because
Sometimes sometimes it's just a function of where you live is how things go.
Yeah.
You might ride a horse if you lived in Wyoming, Montana.
Yeah.
Things like that. All right, get something down for that. We'll move to example 3, I guess.
Yeah, that's cool.
All right. This is actually a really good example of how correlation does not imply causation. So the situation here is the principal of an elementary school noticed that there was a correlation factor between students' shoe sizes and their reading scores. That's a bit of a stretch to think that your shoe size impacts your reading score. Would you suggest that that's kind of weird?
Yeah.
Okay. But the data might show that. Like, it might actually show that if you have a bigger shoe size, you have a better reading score. Okay. And you're like, well, why would that even matter? Well, as students get older, what do we know about their shoe size?
It just gets bigger.
And their reading score should also get bigger, right?
Yeah.
You compare an elementary school to a high school student, you should see a difference. So sometimes they are correlated, but not because of the fact that they're not related. They just happen to go in the same direction. All right, so let's decide if the conclusion is valid. You have to decide whether shoe size actually causes reading score increase. And I think we're saying that it does not, because you naturally have a bigger shoe size as you get older, and as you get older, you get an increased reading score.
Yeah.
So this would be maybe not valid. The whole point of some of these testings, even research, is to draw some sort of conclusion. Like, we want to make,
can say just like not valid or not reasonable or something like that, or
but you want to add some words like that shoe size, while it's correlated to reading score, it does not cause your reading score.
yeah. Got it. Do we have to like back it up with like math or something?
No, there's no math here.
Okay.
What I think maybe isn't clear here is how, because that is somewhat correlated. I mean, that there is some sort of I'll call it association, but there's something happening in some other part of the world right now. Pick your country, pick your thing in that other part of the world that is correlated to what you and I are doing right now.
Yeah.
And they're totally unrelated.
Yeah.
One does not cause the other, but but the data shows that, like, as their thing goes up, our thing goes up. And that's, that's what they're trying to show you here, is like, sometimes they do, sometimes they don't. I believe this one is valid. Let's take a look at it. It says the relationship of the weight of a box and the number of pencils in it is shown by scatter plot. So what they're trying to say is as you add more pencils to the box, the weight of the box goes up. And you have to decide if number of pencils causes the weight to increase.
Yeah, it does.
Does. Absolutely. And there's no like uncertainty about that.
Yeah.
If you're ever in a situation in the classroom where you're not sure, sometimes you just have to change the wording, like the number of Big Macs I eat increases my weight.
Yeah.
And you're like, yeah, it does. One affects the other. Okay, so you want to say something about this one being valid. Maybe say that there is an impact. One causes another.
Okay.
All right, problem C here. This is like the classic problem they want to show you in this class. I think I joked the other day they should switch it up to cell phone, social media, TikTok, Instagram, whatever you like, Snapchat. Armando's mother claims that the number of hours spent playing video games brings down his grades. Armando collected data from his friends and displayed it in the scatter plot shown. He says it does not matter how much time he spends playing video games. His mother claimed that a published research project showed a correlation factor of minus 0.73 between hours spent playing video games and grade point average. And if you guys aren't doing this in class, this is actually a great like discussion point. Just maybe you've done that in English class where you've maybe written some papers or persuasive.
What, hours playing video games?
Well, the whole like, are video games bad for you?
Yeah.
Yeah,
Oh yeah, we've done stuff like that.
cause and effect. Yeah, this is,
I don't play video games, so
you probably spend time on your phone.
yeah, I
Right,
do definitely
right, right.
spend time on my phone, but I don't play video games.
Yeah, but yeah, it's like
Same
this.
thing, yeah.
It's essentially the same thing, and really for adults, as it's just adults do things, time spent, whatever. Like,
Yeah.
the question is, does one really impact the other? Okay, or could it be something else that is causing the negative relationship? Basically, what they're trying to say here is that as you play more video games, your grade goes down.
Yeah.
So if let's go with the premise that that's valid. Okay, that's suggesting that you cannot get good grades if you play video games. Okay, because your
Yeah.
grades are always going to go down. Is that true?
No.
No. I mean, you have plenty of time in the week to do both, to study and to do this. So what could be causing it? Well, I'm sure there's some impact. If you're not spending time studying and you're spending it in front of the computer or TV, yeah, there's going to be a problem there.
Yeah.
The claim, this is kind of like moderate. It's kind of strong to moderate, but moderate here. But there could be other variables, like things like, well, did the student go to class? Did the student spend any time studying? There's lots of other things that could impact your grade. And I think you want to say something here about, this is not valid, and maybe list a couple of reasons why, maybe some other things that could actually impact your grade.
Like zoning out in class.
Okay. How much time do you zone out in class? Like it.
A little too much. But
How about like maybe what kind of your food? I mean, some kids probably don't eat before they go to school, or is the class in the morning or the afternoon? I remember I would have that lunch, and then my class right after lunch, I was pretty tired, wanted a nap. Some people are more of a morning person. Some people are an afternoon persons.
yeah.
Sometimes you just don't like the teacher. So any of those things would be good to put down here for reasons why this is not valid.
Yeah.
But notice they're trying to make a point here. They're trying to say, like, if you just, and that's the other way. They're trying to make this point that if you just stop playing video games, your grade would grow up.
Yeah.
And that's not true, because you might spend that time that you were playing video games doing something else.
Yeah. True.
Besides studying. So that's not necessarily a good thing here. And that kind of leads to this question, which is, why can't you use correlation to prove causation? And it's because of what I said earlier about confounding variables. Usually there's other variables involved, other things that cause causing the relationship.
Yeah.
It's never as simple as one thing. They call this in business, they call it the silver bullet. Have you heard about that idea of a silver bullet?
Yeah, kind of.
So like, vampires, you kill a vampire with a silver bullet, I think. But in business, it's like, if I just had this one thing, I would be successful. And sometimes we do that as it's like, if I was just a little bit taller, if I was just, the if onlys basically. And that's just not reality. I mean, you make what you want of yourself in this world. There
Yeah.
are no silver bullets. You get what you get. You work hard. But two things can be correlated, but it doesn't mean that one causes the other. In fact, there's a lot of other variables that could be causing it.
Yeah.
All right. Last question here. What would be true if the scatter plots of a data set, if the two factors are perfectly correlated? So there's both types of perfect correlation. There's positive and there's negative. And these only occur if every single data point falls on the line. Every data point must fall on the line.
Okay.
This never happens in the real world without
Okay.
manipulating the data.
Oh,
And it doesn't matter whether it's positive or negative correlation, it's the same
okay.
thing. All right. Well, we don't normally have 2 minutes to finish early, but can you tell me something you learned today or something you found interesting?
Yeah. I don't know. I found out that
Sorry to put you on the spot there.
no, you're good. It's